Okay friends, today we are going to see the types of triangles and angles in triangles. Okay, Euclidean Geometry part 5 of 25. Okay, I have this. So types of triangles. Okay, classification of triangles. If we can classify the triangles based on sides, we are going to have three types. Okay, based on sides, we are going to have three types. So we have equilateral triangle, isosceles triangle, and scalene triangle. Okay, this is based on sides. Okay, in a equilateral triangle, you have three sides which are equal. Okay, three equal sides. And because you have three equal sides, automatically you are going to have three equal angles. Okay, the sum of interior angles in a triangle is equal to 180 degrees. So you have three of them, right? They must be equal for equilateral triangle. So the only way to have them equal, you are going to have 180 divided by 3, and then you are going to have 60 degrees. So this angle is equal to 60 degrees, and this angle is equal to 60 degrees, and this angle is also equal to 60 degrees. And for isosceles triangle, you have two equal sides. Okay, automatically you are going to have two equal angles. Okay, these angles that are opposite equal sides, they are known as base angles. Okay, they are also equal to each other. And you also have a scalene triangle. Okay, for a scalene triangle, you have three unequal sides. Automatically, you are going to have three unequal angles. Okay, so this is the classification based on sides. Okay, based on sides, we have three types. Now, based on angles, we have three types. Okay, acute triangle, right triangle, obtuse triangle. Okay, in an acute triangle, you have three acute angles. Okay, three of them, acute angles. This is known as an acute triangle. Now, in a right triangle, you are going to have one right angle. Okay, one right angle, one. And in an obtuse triangle, you are going to have one obtuse angle. So, if you don't know about the types of angles, I suggest you go to part 2 of 25. Okay, now classification based on sides and angles. We are going to have equilateral or equiangular triangle. You are going to have acute isosceles triangle, isosceles right triangle, obtuse isosceles triangle, acute scalene triangle, right scalene triangle, obtuse scalene triangle. So this is an example of isosceles right triangle. Okay, one right angle and two sides are equal to each other. Okay, isosceles meaning two sides are equal to each other. Right triangle meaning you have one right angle. Okay, you can see that. So this is 90 degrees. The rest, you're going to have 45 degrees and 45 degrees because the two sides are equal. Okay, isosceles, the two sides are equal. Automatically, you are going to have two equal angles. Okay, so it can only be 45 and 45. So a right triangle can be isosceles or scalene, but can never be equilateral. Okay, in an equilateral triangle, you have three angles, all three angles equal to 60 degrees. Okay, so you understand you cannot have a right angle inside equilateral triangle. And an obtuse triangle can be isosceles or scalene, but can never be equilateral. Okay, all angles, they are what? Acute. This is an acute angle. Okay, so not obtuse. If you don't know about the types of angles, I suggest you go watch part 2 of 25. Okay, let's move on to the next slide. Okay, you are given this triangle. Okay, triangle ABC, and this side is equal to this side. Okay, AB is equal to AC. Okay, AB is equal to AC. If we call this angle theta and we call this angle beta, automatically theta is equal to beta because the two angles are opposite equal side. This angle is opposite this side and this angle is opposite this side. Okay, this angle is opposite this side and this angle is opposite this side. So because the two angles are opposite equal side, they are going to be equal to each other. Okay, so they are known as base angles. Okay, base angles are angles that are opposite equal sides. Okay, so theta is equal to beta. Okay, so in a triangle, angles opposite equal sides are equal. Okay, angles opposite equal sides are also equal. Or you can say sides opposite equal angles are equal. Okay, sides opposite equal angles are also equal. And again, in a triangle, if you have a triangle, you have an exterior angle. This exterior angle is equal to two interior opposite angles. Okay, this exterior angle is equal to two interior opposite angles. Okay, exterior meaning outside, interior meaning inside. So the angle A is equal to the angle B plus the angle C. In words, we are going to say the exterior angle is equal to two interior opposite angles of the triangle. And in a cyclic quadrilateral, we are going to see this in 7 of 25. Okay, 7 of 25. So let me give you this for now. The exterior angle equal to the interior opposite angle of a cyclic quadrilateral. Okay, when you have this, so the angle A is equal to the angle B. Okay, angle A is equal to the angle B. We are going to see this in 7 of 25. Okay. Okay, now let's practice what we have seen so far. Okay, you are given this question. Okay, you can pause the video and read the question. So calculate with reasons the size of each of the following angles. Okay, angle R, this is R, ONR, ONR, you have this entire angle. So let's start with question 1. You are given the angle P. So this is given. Okay, you are given. Now, can you see? You have the U shape and PM is parallel to OR. Okay, so this angle plus this angle, you must have co-interior angles. Okay, remember the mag, the U shape. The two lines are parallel to each other. So the angle P plus this angle, which is POR. Okay, POR, you have this angle. You must have 180 degrees. The reason is co-interior angles PM parallel to OR. Okay, so this angle is equal to this minus the angle P when you take the angle P to the right. So this is equal to this minus, okay, you are going to have this angle equal to 114 degrees. So this angle is equal to 114 degrees. Okay, POR. POR. You have this angle which is equal to 114 degrees. Now the question is to find R, okay, the angle R, and in question 2 you have to find ONR, okay, ONR, this angle. Can you see you have a triangle? So this is an exterior angle of this triangle. So this exterior angle is equal to two interior opposite angles. Okay, remember from the previous slide. So this angle, the angle R, plus this angle, the angle ONR, they are going to be equal to 114 degrees. Okay, the angle R plus the angle ONR, they are going to be equal to 114 degrees. And the reason is exterior angle is equal to two interior opposite angles of this triangle. Okay, so this is the reason. Exterior angle of triangle ONR. Okay, you can write in short like this. Now we carry on. ON is equal to OR. Can you see this is a radius and this is also a radius? Okay, from center to the circumference, from center to the circumference. Okay, you have two radii. You understand? The two radii are equal to each other. So OR is equal to ON because they are radii. Okay, radii. So OR is equal to ON. The reason is radii. So the two sides of this triangle, they are equal to each other. Automatically, the angles opposite the equal sides, they are going to be equal to each other. Okay, so this angle, so the angle R is equal to the angle ONR, this angle, because these are angles opposite equal sides. Okay, this side is equal to this side. Okay, because of radii. The reason is angles opposite equal sides. So to find the angle R, this is equal to, you are going to take this because you know that the angle R plus this angle, this is equal to 114 degrees. So for you to find this angle, you are going to divide this by 2 because the two angles are equal to each other and their sum is equal to this. You are going to divide by 2. You are going to have 57 degrees. And so question 2, this angle is also equal to 57 degrees. Okay, so we are done with part 5 of 25. Please check for part 6 of 25.